Ladies and gentlemen, boys and girls, grandpas and grandmas, aunts, and you know what, you get the point. Welcome! Today we are going to be talking about Arduinos, NodeMCUs, Particle Photons, all good stuff. We're going to be comparing them, talking about their differences. Let's start off with the most recognizable and probably well known in the maker community, the just standard Arduino. This is an Arduino Uno board. Now the term Arduino itself is actually a little bit confusing. The easiest way to think of an Arduino is as a spec. Anything that fulfills the spec, aka any chip that can be programmed in a specific way and meets some other requirements, is considered an Arduino. So for example, we'll be talking about these little guys later. This is an ESP8266, the little module, and the whole board is a NodeMCU. These are actually Arduino compatible, so they can be programmed with the standard Arduino IDE, but they're a completely different microprocessor. If you're just getting started, something like this, an Arduino Uno, is an awesome place to start. There's really nice pre-made IDEs for programming Arduinos. You just shove a cable into here, shove the other end into your computer hole, and it's pretty easy. Most Arduinos definitely fall under the embedded processor category, aka dirt slow. This particular Arduino, I believe, is 8 megahertz, maybe 16 megahertz, something like that. According to that oscillator right there, it would be 16 megahertz, I think. Anyway, let's talk really briefly about what you're looking at on these boards. The microcontroller itself is this little guy, and it's just socketed into the board. It's a pain in the butt, so I won't rip it out, but it looks like this. You might ask why I have a second one of these. It turns out that they don't like 24 volts very much. The rest of the stuff on the board is just supporting. By the way, electronics is just a hobby of mine, so take everything I say with a grain of salt. I'm fairly sure this is the external oscillator. It provides the clock for the microcontroller. A lot of Arduinos you can buy have an oscillator built right into them. For example, this is an ATtiny85. You can see it's appropriately named. These guys are really cool little chips. They've got a built-in power regulator so they can take in 5 volts. They've got a built-in oscillator. So quite literally, you need to provide these nothing but power, 5 volts, or I think you can provide them 3.3 volts as well. I'm not sure on that one though. And they go. They're obviously slightly limited on how many pinouts they have. On a lot of Arduino boards and just development boards in general, you're also going to have some power stuff over here to regulate the 5 volts into whatever other voltage is needed, usually 3.3 volts for the microcontroller. You're also usually going to have a USB if it has a USB connector. You're going to have a USB to serial interface. And then I don't know what this stuff is. I would guess maybe flash memory. I'm not really sure. You're going to have the all-important LEDs. You can't get by without those. And even more importantly, a very satisfying button to push. Anyway, Arduinos, what they're good at. Controlling electronics and a lot of really real-time stuff. If you want to take in some sensor data, say from a humidity sensor or a temperature sensor, and you want to spin a servo, these little guys are really good at that. They can also be put in incredibly low power saving modes. These little ATtiny's, for example, can run on a coin cell for upward of a year, depending on what they're doing. If they're just checking a sensor every so often, the deep sleep will last at least a year on a single coin cell, so they use very little power. Now at 8 megahertz or 16 megahertz or 1 megahertz, whatever it's running at, different Arduinos run at different frequencies, you're not going to be doing a whole lot of computation. I would not recommend using Arduinos for your next supercomputer cluster. But these guys are really awesome for electronics projects. I would highly recommend, if you haven't already, grabbing one of these and just start playing around with them. They're fairly easy. Now let's step up the game in power a little bit. This little guy is a particle photon. Or more technically, this little square in here is the actual particle photon. A little hard to see, and it's wrapped in a whole bunch of junk because I use this for something and it connects and disconnects very nicely. So the particle photon itself is of course just this little board here. Now these guys are a little bit different than your standard Arduino. These little guys run at a significantly higher clock frequency. I believe the particle photons are 120 megahertz. So you can do a lot more substantial work on these things. They also have a built-in Wi-Fi module, and the particle photons especially stand out among other Arduinos with similar hardware like built-in Wi-Fi and high clock frequencies. These little guys are actually programmable from a cloud-based IDE. You open a browser, point it to their IDE, you get this guy connected to Wi-Fi, which you can do through their little application, and then like magic, you click flash in a web page and somehow the code gets to here. We'll do another video talking about how exactly that works. It's not actually magic, and it's something I plan on replicating on these little guys, the NodeMCUs. But back to the Particle Photon. The big advantage that these guys have is that they're very turnkey. I would say they're almost as turnkey as a standard Arduino Uno, but if you're an idiot like me, you will run into some frustrations, because if you run an infinite loop of code on this guy, it never has a chance to process any of the Wi-Fi data, which is how it receives updates. So the number of times I've been slamming my head against a wall trying to figure out why this thing won't connect to the cloud, only to realize I'm running an infinite loop on it, let's just say it's many. And unfortunately, a lot of the work that you do in electronics is very infinite loop centric. So you have to keep in mind how these guys work. They're programmed in C++, just like standard Arduinos, and the code that runs on them is very, very similar to standard Arduinos with minor differences. A lot of the libraries that are written for Arduinos are fairly easy to port, sometimes with exceptions, but these guys are not a far cry from standard Arduinos. In the same hardware category are these little ever so popular modules. This is an ESP8266. The actual ESP8266 is just this little square right there. You might be able to just make out that it's one board mounted on top of another. But these modules by themselves are not terribly easy to use. For example, they run on 3.3 volts, so at a minimum you're going to need a level shifter. And I've heard that using the GPIOs directly is kind of a pain in the arse. So this whole board is called a NodeMCU. This is the dev kit. It comes with things like a power supply, a standard USB to serial converter, the all essential LEDs, and of course, the most important thing, little tiny buttons. I gotta say, points against the NodeMCU, the buttons are just not as much fun to push as the Arduino Unos. Anyway, I feel like that might be slightly off topic. In terms of hardware, these guys are very similar to the Particle Photons. They run at either, I think it's 80 megahertz or 160 megahertz. You can actually change it in software. They have built-in Wi-Fi. They have oodles of GPIOs, with the exception of only having one digital to analog converter, aka only one of the pins can input an analog signal. And they have a lot of the cool hardware you'd expect, like a universal serial interface, among other things. The really big advantage to these ESP8266 modules, and the reason that you see them everywhere on the internet, is that they are dirt cheap. No, I'm serious. You go try to buy dirt, and I bet you it's going to cost more than one of these guys. Go right now, go to Home Depot. For just the module itself, you can easily find these guys for under $1. A lot of dev boards you can find for around $1, $1.50 mark. These NodeMCUs come in at a little bit on the expensive side. I think they're like $1.50 to $2, something like that. They are dirt cheap. Now there's a couple ways to program these. They don't have that nice fancy cloud IDE. So you can either use the standard Arduino IDE and program them in C++, just like you would any other Arduino. Plug a cable into this hole here and plug the other end into your computer hole. And click flash, voila, you're done. No, not that flash, the one on your computer. The NodeMCUs, however, are a little bit special. They actually run a little teeny tiny itty bitty Lua runtime. So they run the scripting language Lua. Now that opens up all kinds of really cool possibilities that are now fairly easy to do, like doing over Wi-Fi flashes of new code. We're going to be doing several episodes on these guys. I plan on using them in many projects, and what I actually plan on doing is replacing Lua with Python. There's a Python runtime called MicroPython, which fits in about 500 kilobytes of memory and a little tiny bit more if I remember correctly. These guys have 4 megabytes on them, so 500 kilobytes on embedded is a whole boatload of memory, but these guys have a boatload more. It's kind of funny to consider 4 megabytes being a boatload of memory, but that's the world that we're in. The learning curve on these guys is much steeper. You need to kind of have a solid idea of how these things work, what serial actually is, how to flash firmware, how to build firmware, etc., etc. But they're all open source, which means you can hack these guys, you can add things to them, and they are really cool. So again, if you're just getting started in the hobby, grab yourself one of these. The kits usually come with the dev board, the actual microcontroller, which is an Atmega something, I don't really care, as well as a breadboard, and this fancy little piece of wood to bolt it down to. With this, you can rule the world. 16 megahertz is plenty. I'll be doing several videos later on talking a lot more about many of these, especially the NodeMCUs and the ESP8266s in general, but maybe also some AT-tiny stuff. These guys, by the way, are also dirt cheap. I'm sure if you bought these in bulk, you could pick them up for a penny a piece. And we're going to be hacking on these ESP8266s to add some really cool functionality. Thanks for watching, everyone. Go grab an Arduino and do some epic shit.